Welcome to our video on the basics of acids and bases. To start off, when you think of the term acid, what do you think of? Do you think of bananas? What about apples? What if I told you both are acidic? Would you believe me? I know what you're probably thinking. What even is an acid? Well, for starters, let's make a list of some of the characteristics or properties of acids. Acids give foods a tart or sour taste. Lemons have citric acid, which makes your mouth pucker. Acids cause certain chemical dyes called indicators to change colors. Now, like ranches need cattle and ducks need to waddle, acids need bases. Kind of like iPhones need cases. Bases are the opposite of acids. Bases taste bitter and feel slippery. However, they also change the color of indicators. Okay, now that we have covered some properties, let's define an acid and a base.
That's sort of a trick question because acids and bases are defined three different ways. The first definition was proposed by a real baller named Svante Arrhenius in 1887. He said that acids are hydrogen-containing compounds that ionize sealed hydrogen ions in aqueous solutions. To cut to the chase, acids are hydrogen ions in water. He also said bases are hydroxide ions in water. This definition wasn't good enough for two homies in 1923. Their names are Johannes Bronsted and Thomas Lowry. Their theory defines acids as a hydrogen ion donor and a base as a hydrogen ion acceptor. Let's just say that acid is all about the base. However, Mr. Gilbert Lewis wanted in on that acid-base action, so he proposed a third theory saying that during a reaction, acids accept a pair of electrons while the base donates a pair of electrons.
Now it's time to get down to business. There are a couple of terms you need to know. The first term is the ion product constant. This term is the product of the hydrogen ion and hydroxide ion concentrations. The product of the concentrations is always 1 times 10 to the negative 14th power. The concentrations for hydroxide ions or hydrogen ions can vary as long as the product is 1 times 10 to the negative 14th power. An acidic solution has a higher concentration of hydrogen ions than the concentration of hydroxide ions. If the concentration of hydrogen ions is greater than 1 times 10 to the negative 7th power, the solution is acidic. If the concentration of hydrogen ions is less than 1 times 10 to the negative 7th power, the solution is basic. If you have the hydrogen ion concentration, then you can solve for the hydroxide ion concentration or vice versa. Simply divide the ion product constant by the concentration of hydroxide ions or hydrogen ions. Let's talk about our next term, pH. pH is the negative logarithm of the hydrogen ion concentration. The value for pH can range from 0 to 14. Any value lower than 7 is acidic, and any value higher than 7 is basic. Another term that can be used to measure concentrations is pOH. Simply put in the negative logarithm of the hydroxide ion concentration. When the pH and pOH are added, they always equal 14. You can use this to solve for one or the other. Now you are probably asking what happens when the pH or pOH value is equal to 7. This simply means there is an equal concentration of hydrogen ions and hydroxide ions. The solution is not acidic or basic. Let's relate this to one of my favorite subjects, comic book movies. Let's talk about Batman versus Superman. If acids were Superman and bases were Batman, a pH or pOH of 7 would be Wonder Woman. Wonder Woman is sort of doing her own thing while the boys are duking it out. This Switzerland of solutions is called a neutral solution. Pure water is the perfect example of a neutral solution. Acids, bases, and neutral solutions are essential in our everyday lives. They help us clean our homes, digest our food, and even give our food its flavor. That's pretty much all the basics for acids and bases. Thank you for watching.